problem session. Okay, so this is a good problem. This is actually also a very standard problem. So sometimes this is a problem that actually requires an integration. So if you not good integration, you probably can do up to the point of integration and then like setting it up and things like that. Okay. So here are a whole bunch of assumptions we can make. It's a raindrop and is a spherical of radius r. Mass is m and coefficient of viscosity is eta. This is later not n but eta. And Stokes' law is this thing and opposed to velocity. Very important. Viscosity opposes the velocity. Okay. All right. And now this whole thing is constant. So no need to keep writing it like that. You can just call it B. And you can see that because V depends on time, this will depend on time. So this is some instant t. This is the situation. All right, how do we find V of t? All right, so this is the speed, but we need to write F equal to ma. So how do I set up F equal to ma? Well, so F equals to ma. The reason we need F equals to ma is because there's a force given, and so how do you set this up? To set this up, I'm just going to use the letter M. Easy to write, just one stroke. So F is going to be all the forces. You need to identify all the forces. So we already know that viscosity is kind of laminar. Stokes' law is saying laminar velocity, viscosity. So it's viscosity, this kind of flow of air around the ball as the ball is going through, cutting through the air. So if you look at the force picture, you have this guy pointed that way. And then of course you have a weight of this thing. So another force is pointed weight of this thing this way. And this is a vector equation, so let's see y-axis is pointed that way. So we're looking at y. So F V is pointed that way. So if you write this as a vector, this guy viscosity force a vector is going to be minus 6 pi eta r. And it's going to have velocity vector and the minus sign, so that this is opposite to that. So over here, the y component will be, this is, we're writing b for that, so minus b vy. So it's going to be minus b vy. It's important to write it like that, otherwise you may get confused with, should I write bvy or minus bvy? That's going to be, that's a source of error. This put minus or not, okay? Plus, what we're going to get is mg is pointed down, opposite is the velocity. So it's going to be minus mg. And on the other side will be ay. So this is a function of time, and this is a function of time. It looks hopeless till you recognize that this is nothing but dvy dt. So right side is like that. So if you write down vy minus mg, you write it like this. It looks like a equation for derivative. So this is a type of differential equation. It's a simple differential equation. Of course, when you study differential equation, you're going to study a lot more complicated differential equations. So let's divide every by m, and this goes away, b over m. Of course, you have a b over m is 6 pi eta r over m, and let's call this letter C. So you have a dvy dt equals minus c vy minus g. C must be unit of, if this is one of, you can see this, so C unit times meter over second must have the same unit as this guy, meter per second squared. So C unit is 1 over second. So it's some kind of rate. Okay. Now this is you can solve this and couple of different ways. Let's take C out common, and now you can see that I can use that as a new variable. Then this will be du dt is same as dvy dt dg over c dt, but this is constant, so 0. So this is dvy dt. So this equation here just turns into du dt minus cu. So this just solves du over u minus c dt. So if I go from c is constant 0 to t, then this u at 0 and u at t, u at 0 and u at t. So this is going to be log u of t, u of 0, right? How did I get there? Okay, let's not skip. So this is going to be log u 0 ut. On the other side, we minus c t 0 t. So on the left side, I'm going to have log ut minus log 0 t minus 0. So this minus ct, and on this side is log u of t over u of 0. So this side equals that side exponentiated. So u of t over u of 0 is e to the minus ct. That means u of t equal to u of 0 is a minus ct. But I don't want u, I want v. And this is the relationship, so let's write down this will be v y of t minus g of c. So this is the left side. On the right side is going to be vy of 0 minus g over c minus ct. Now we say at rest, so this is 0. So at any time vy of t is equal to g over c minus g over c e to the minus ct. And you can see that as t goes to infinity, this goes to 0. So it actually, if you look at Vy, this is the speed part, you start with here, and so t equal to 0, it's 0. This part goes to 0, and then in the end it goes to t goes to infinity. Let me do it more properly. T goes to infinity, nothing happens to this guy, it remains g over c minus g over c times 0, so g over c. So this is what its terminal velocity is. Okay, so and t equals 0, it was 0. So it reached terminal velocity here. Let's call it v subterminal. That's the terminal velocity, not that. Let's see. This is the terminal velocity. So this will plot go all the way like that. All right. So we catch the terminal velocity as well as what the Vy should look like. The speed will just be absolute value of this thing. All right. Okay, so hopefully I didn't make some stupid error somewhere, sign error. But this is a decent problem where you kind of learn to solve problems, simple problems like this. Where else this kind of thing shows up? It shows up in capacitor problem. When you're trying to charge a capacitor, so this kind of thing will show up in a capacitor problem. So here is a R, C, and switch. At t equal to 0, you start the switch. So what will happen is initially capacitor is uncharged. All the voltage is going to drop here, so this is going to be initially all the current will be like this, but later on this charge will build up. There will be plus q here, minus q here, and as charge builds up to at certain time t, as charge goes all the way at q at time infinity, and this becomes a minus q, so this charge will build up, and so current will start to get less and less. Eventually this will be fully charged, and all the voltage will drop just across here. So q cv, when that much charge is built up, that's like a terminal charge. So if you were to draw, say I want to find out q versus time, initially it was 0, but it's going to end up with this. And I'm not doing this problem, but if you do this problem out, you'll find the equation for q dq dt will be same equation as we found over here, same type of equation. So like this will come from resistance will create this part, capacitance will create this part, and this is the voltage part. So in this circuit, you have a resistance. So I is dq dt. So the voltage drop here will be Ri of time t, and so it's going to be Ri r dq dt. And over here, when the charge is these guys, then it's going to be q t over c. That's the voltage drop here. So voltage drop here plus voltage drop here will have to equal to voltage drop here. So you'll have a looks like I did the problem dq dt plus 1 over c qt will have to equal to the voltage that the battery is providing, V0. Let's call it V0. This time independent, because this battery, it maintains the chemicals there maintain the voltage. So this equation will be identical to that equation. All right. Okay, so maybe you want to solve this, and maybe in the future when we do the electricity part, these kind of problems will show up. Till then, till the next problem, don't forget to subscribe and tell your friends about this channel. I will see you in the next video. Bye.